successfully grabs or something or not. Well, so as long as integer stays, as long as the entity ID integer is unique as well, which it should be, because they don't use a UUID, then this should be fine, just the same. And UUIDs are large, they're strings and stuff. I'd rather just deal with integers. So yeah, if grabbed hash set contains it, then we return false. If grabbed hash set doesn't contain it, then our own most definitely should not. So what we can do here is, so what we do here is we do grab set plus equals entity dot get entity ID. We do actually want to make sure we update the global thing first. There you go. So this grabs the entity. All this does at this point in time is basically check against our global set, and then if it doesn't contain it, add it to the global set, add it to our set. Great. No, don't say that. Don't say that in arrows, please. No, I don't want to have to deal with that. For now, we'll just do this. How about that? Okay. And then the same thing we're gonna do. We move entity. If our grabbed set contains entity ID, do all this, else false. So if our grab set contains entity ID, then we need to grab set minus equals entity ID and grabbed. We want tile grasping finds that grabbed hash set minus equal entity dot get entity. There you go. Okay. All right. So, whoops. With this, we now have our basically things to say to add things to our grabbed list, both the global one and our local one, and vice versa, to remove things from it. We don't actually do anything with this yet, but this is kind of just getting the easy framework out of the way. The things to consider with this right now is how does it maintain state? Basically, once if this chunk containing this thing loads or unloads, is it going to remember the IDs of the entities that it loaded or not? Is the I don't even know if the entity ID actually persists between loads, so let's go check that out right now. So I'm trying to look for entity, basically save load, right to MBT. So if this, it it does not. This does not save its identifier. It does save its UUID. It does not save its identifier. Oh, get unique ID. Okay, this does get UUID. Okay, great. Great. So that's what we're going to have to work off of instead. So we go back to tile grasping finds. We go off of UUID. We want its unique ID, not its entity ID. So entity ID is probably the temporary thing that it uses in local memory. The unique ID is what it actually uses to maintain state between save loads. Yeah, I just didn't find it previously. I was looking at. Yeah, I wasn't actually looking for it before. So this should be fine. This should be fine now. Which means that we can make the state persist between save load. There's a bit more interesting cases, so let me bring up paint. So here's the fun bit, okay? So here's a little global state tracker. So imagine here's a chunk. And we have a grasping vine here, and we have a grasping vine here. And we've got some item here. Let's make this red. So in some world, let's say this grabs that. So this. So now this says this one has it for that item, which is all fine and good. So here's the interesting bit: is that let's say red is specifically. So okay, what this is a chunk boundary right here. So let's say that what did I have before? Say that red is on the right chunk, and let's say this unloads. So now this is pointing to an object that's to a thing that doesn't exist. So which we can do that. We can look for an entity, find that it doesn't exist, and then we just don't do anything with it. We could cut the connection. We could just hold on to it and wait until this entity reloads, in which case this association's maintained over save load. But if this unloads, the question is what to do with that. So we could have it stay here, except this is in memory only. This isn't persist with the save load of the world. This is some particular state. So in that case, this doesn't really last. This isn't particularly good for maintaining things between save load. So what we could do is when this unloads, we cut this connection, because when we can't find something in our list that's there, we strike it from that. We strike it from, because this has its own list. We strike it from this list, which is great. No. Unique ID. That's the universal unique identifier. That's kind of a standard set forth. The way that works is actually 4 different identifying algorithms, and the unique ID is a string, which tells you what algorithm was used, what timestamp it was used at, and what call into that algorithm was what call, basically, like, so if I call that 33 times in a single timestamp, it'll increment. It has something. It'll also increment itself to say this is the first call on this timestamp. This is the second call to this algorithm, and then that's all metadata. That's also part of the final UUID, in addition to the actual bit of random strings that's appended to either the front or the back. So it's literally a universal identifier, because it's not only based on timestamp, but also how many calls into said timestamp and which algorithm was used in that timestamp, plus the output of the randomization algorithm. Yeah, so there is a simple check to see if the chunk is loaded. The thing is, I'm not. The thing is, these things will only tick if the chunk is loaded, and so I'm not remembering the chunk that all these things are in. I'm remembering the name of the item, which right now it could be better, because I'm actually not. This is wrong. I'm not actually linking to this. What I'm actually linking to is, here's the Minecraft giant world object, which says I have an object in memory of this name. So what's actually happening is this is going like this and saying, hey, I have an object name. Find me that object. Right. Yeah. So what's actually going to happen is, if this chunk unloads, then that's the world causing the chunk unloading. The world's going to drop this. So this is gonna kind of ask the world, hey, I've got this identifier, and the world kind of like raises its hands and says, I don't know what you're talking about. There's nothing of that name. So what I could do is I could make a direct reference to the item instead of the name, but which fixes part of the problem, except that then that becomes in memory. So if this item goes away, this needs to check to see if this item went away. So if the world then cuts this connection, this doesn't see the fact that the world cut connection, like the item gets picked up or deleted or unloads. So that's the one problem. The other problem is, for example, say somehow this links onto this object first, even though this one's closer. Like this ticks first. Now let's say this unloads. So if that connection is supposed to stay, well, the item doesn't know that this is connected. This is in memory. This one was going to mean you're going to latch on, and now we've broken our. Yeah. So the thing is with these lashing vines is that basically I have to operate in memory. I can't do any save load across. So basically, what's going to happen is it's gonna be weird, because what has to happen is basically chunks are loading. This chunk loads. This guy has no connection. Basically, let's say the world's loading, so it loads this chunk. Then it loads this chunk, and now there's this entity. If Minecraft loads chunks before ticking them, so then it'll tick in the same order. It'll tick this chunk, this will be in range, and it'll connect. And that gets added there, and then this will try and say, oh, that already has something attached to it. I'm fine. Now, the interesting bit is, if this unloads, like the player was just enough to load both of these chunks, and then the player moves one chunk over, but this is still in this chunk, this is now going to latch onto it. The most robust, but it's also the most complicated, needlessly complicated. Like I can just do it all in memory. There's nothing that has to be with it. I'm just anticipating the weird behavior that comes out. The weird behavior is going to be that this, which probably should have been attached to that, now gets attached to that. And gets sucked in over here, which only really matters if you have multiple things that have been grabbing at the same stuff, and there's a different, you really care about the order that it attaches to them, and you really care about which of these that it flows into, because these are item grabbers, basically. And that only really happens if the chunk state between the two chunks is also going to be churning, and it's not going to be these two are loaded all the time, or these two are unloaded all the time. So that's kind of like at that point, there's so many ifs, ands, and buts. I'm kind of okay with just saying that, you didn't stabilize your setup. There's gonna be some weird behavior on it. That is an interesting solution, but now this needs to know which thing has that, right? So now the global list, because I'm going to the identifier, which this points to. So I can look up this in here, but now this has to be able to look up that based on that. If the entity is enclosed in blocks, right now it's going to grab it and keep pulling it into the blocks, pretty much, which is a physics thing. It should bounce back, hopefully. It is kind of a mess, but I could do a raid check. At that point, how do you keep the raid check going, like while you're staying connected to it? Do you have to raid check to connect to it? Like, that's one of the interesting bits. So for now, I'm not going to worry about saving your list of stuff. If you unload, you drop your connection and you unregister the item connection from here. So that way this will be up for grabs and this one will be able to grab it. And that simplifies it a whole lot. So what I can do on that is there's a function that's called, oops, that's not what I wanted. It's a function that's called by Minecraft called invalidate. This is when the tile entity is invalidated. Basically, the tile entity unloads. It's no longer in the world. It shouldn't tick.